Happy Monday. Today, sorry, misplaced my pens and all of a sudden I'm looking for them. Today we're going to be looking at normal distribution problems, so very similar to what we did last Thursday. In fact, we're going to be using the same online calculator. I put it into your, into the assignment, the link, I put it in there. But this time, instead of always having a mean at 0 and a standard deviation of 1, we're going to look at some problems that don't have that. So, when you have these type of problems, there are 3 steps that you need to follow. So the first step is to state the distribution and the values of interest. And what I mean by that is draw your normal curve, and on your homework I did put the template. You will have the template, and then you should make sure that you have your area of interest shaded, and you need to label what your mean is, your standard deviation, and then the boundary values that has to do with what you shade. And you'll see what I do in a minute. Perform the calculations. I'm going to have you, sorry, I'm thinking this through. You're going to use the calculator. We'll see if I have you write it out. With my AP statistics, they have to write it out because when they take the AP exam, if you don't write it, you don't get credit. But I can hear Ian in my head going, don't make us write it out. All right, Ian, that's fine. And then step 3, answer the question, use complete sentences. So last time we were only finding a proportion or a percent. Now we're going to actually answer it like a story problem, so make sure that when you answer it, you write a complete sentence. So first one that we are going to look at, I'll move it up in a minute after I read. So it says, on the driving range, Tiger Woods practices his swing with a particular club by hitting many, many balls. Sorry about my typo. Suppose that when Tiger hits his driver, the distance the ball travels follows a normal distribution. All of these questions will tell you that it follows approximately a normal distribution, or you can assume that it's normal. We have a mean of 304 yards and a standard deviation of 8 yards. So the first question, what percent of Tiger's drives travel at least 290 yards? So I'm going to draw a line up here. I'm going to draw my normal curve for A up here, my normal curve for B over there. So I'm going to do my best to make this look normal. And if you're drawing your own, which you should be if you're taking notes, see how mine didn't even turn out perfect. I'm not going to be angry if your normal curves are perfect, okay? Do your best. But on the homework you have a template. So normal, the mean is 304, standard deviation is 8. So we're going to go through and we're going to label all of those little hash marks. So the mean 304 is at the center. 1 standard deviation above 304 plus 8 is 312. 2 standard deviations above would be plus 8 again, so 320. And then 3 standard deviations again would be 328. 1 below would be 304 minus 8, which would be 296, and then minus 8 again would be 288, and minus 8 again would be 280. So the question says, what percent travel at least 290 yards? Remember, at least means it could travel more than. So 290 is approximately here-ish. So that's 290. At least would be greater than. So we're looking at this area under the curve. Now, like I said, that online calculator, I put the link under the assignment. But we're going to switch over to it really quick. So we're looking at the normal distribution calculator. Now, on Thursday, we focused on the mean always being 0 and standard deviation always being 1. But today, our mean is 304, and our standard deviation is 8. And as you can see, we're looking at the area above, and we're looking at the area above 290. So above 290, I'm going to hit enter, and I get 0.9599. So I'm going to switch back. So we got 0.9599. The question is asking for percent, so that's 95.99%. And then we need to make sure that we answer the question using complete sentences and put it into context. So that'd be something like, at least 95.99% of Tigers drives. I don't know why I put at least there. Sorry. Of Tigers drives travel. 95.99% of Tigers drives travel at least. That's where I went. At least, sorry. It's a really good thing I don't teach English. At least 290 yards. I suppose I could have said, no, I don't even know how I would have started it with talking about the yards first. Sorry. So I put it into context. I answered the question. 95.99% of his drives travel at least 290 yards. Now this one, what percent of Tigers drives travel between 305 and 325? So again, I'm going to draw my normal curve. Nope, sorry, I knew I wasn't going to have a good one if I started that quickly. That's a really wonky normal curve. All right, and then same numbers over here. So 304 at the center, 312, 320, 328, 296, 288, and 280. So this time we're looking at between 305 and 325. So 305 is just slightly over the mean, and 325 is somewhere between 320 and 328. So we're looking at this area. So then I almost forgot, we need to label that's normal with mean of 304. Standard deviation of 8, that's 325, and this is 305. So we're going to jump back to our calculator. Notice this time we're looking at the area between. So the mean and standard deviation are the same, but I'm looking between 305 and 325. Hit enter, and I get 0.4459. So again, on this one, it's asking for a percent, so we're going to change that to 44.59%. And then we're going to put it in a complete sentence with context. So, Tigers drives are between, abbreviating between there, 305 yards and 325 yards, 44.59% of the time. Now, on the next couple of questions, I want you to pause and try them on your own first. This time instead of golf, we're looking at tennis. So in a recent tournament, tennis player Rafael Nadal, I have no clue if I said his name right, sorry if you're a tennis person and I butchered it, he averaged 115 miles per hour on his serves. We're going to assume that the distribution of his serve speeds is normal with a standard deviation of 6 miles per hour. So it tells you that we can assume the distribution is normal. We have the average or the mean, and we have our standard deviation. So I want you guys to pause, try these, draw your pictures, use the calculator, put your answer into a complete sentence, and then you can double check that you got what I got. So first, draw my normal curve. Sorry. So on this one, we want to figure out what percent exceed 120. This is normal. Average is 115. Standard deviation is 6, so 115 at the center. Plus 6 would be 121, plus another 6, 127, and then 133. And if we subtract 6, that's 109. Subtract another 6, 103. And one more 6 would be 97. So, let's see. Exceed 120. So 120 has got to be like here-ish. 120. And exceed is greater, so we're looking at that area. So when I go to my calculator, I'm going to change the mean to 115. Standard deviation is 6, and exceed, so that's above 120. I'm going to hit enter, and we get 0.2023. So 0.2023. Question wants percent though, so that's 20.23%. So in a complete sentence, 20.23% of Nadal's serves exceed 120 miles per hour. And then on B, we want to figure out what percent are between 100 and 110. Sorry, I have an itch on my nose. So I'm going to draw my normal curve. Same numbers. So it's normal, average 115, standard deviation is 6. So that would be 121, 127, 133, 109, 103, 97. So I'm going to estimate 100 should be like right halfway in between there, and 110 is just slightly past 109. So we're looking at that area. That would be 100, and that'd be 110. Oops, sorry, just slightly below the corner of the camera there. So 100, 110. Jump to my calculator. Still working with the same mean and standard deviation. This time I'm choosing between 100 and 110, and I get 0.1961. Question is about percent. So Raphael serves are between, abbreviating between there, 100 miles per hour and 110 miles per hour, 19.61% of the time. All right. So your homework is going to be like this. You need to draw a picture. Well, shade the picture because I gave you the template for each one. And then make sure you put your final answer in a complete sentence for me, please.